Hello everyone, welcome to my channel Mathenthusiasm. Today we're going to look at this challenging limit of cosine. Our first impression might be L'Hopital's rule. However, I will show you why this powerful rule is not a good choice for this question. After that, I shall walk you through a better alternative in great detail. First thing first, both numerator and denominator are composite functions. To apply L'Hopital's rule, we'll have to use chain rule. This is not straightforward. Let me show you the first few steps. Now you can see that when differentiating the first time and the second time, the limit is getting more and more complicated. The key point here is not the technical details. Instead, it is not very clear at which step we can stop differentiating. You can check out my previous video when the L'Hopital's rule fails for more interesting examples. The link is in the description below. So what should we do? Now we're going to use a couple of elementary tools to find the limit. First of all, how do we usually deal with the square roots? Well, we have to do quote-unquote rationalization. So for the term 1 minus square root of cosine x, let's multiply both numerator and denominator by 1 plus square root of cosine x. They are of the form a minus b and a plus b. We call this a conjugate pair. The numerator is the product of the pair, which is the difference of two squares, a squared minus b squared. So it is simplified as 1 minus cosine x. For the two brackets in the denominator, we just copy them without expansion. Can you see that these two terms are in the same format? Actually, both of them are 1 minus cosine some angle. Let's recall the double angle formula. Cosine 2 theta is equal to 1 minus 2 sine squared theta. Rearrange the terms, we'll have 2 sine squared theta is equal to 1 minus cosine 2 theta. So for the numerator, we put 2 theta is equal to x. That is, theta is equal to x over 2 to get 2 sine squared x over 2. And for the denominator, we put 2 theta is equal to square root x. That is, theta is equal to square root x over 2 to get 2 sine squared square root x over 2. Let's replace these two terms by the sine terms, so we get this limit. Now, the constants too can be cancelled out. Moreover, we put the sine terms together, so they're under a single bracket. Next, our goal is to get the form sine theta over theta. Why? Because for trigonometric limits, we're going to use an important result, which is limit of sine theta over theta is equal to 1 when theta tends to 0. So for the numerator, we divide x over 2. And for the denominator, we multiply square root x over 2. To keep the expression unchanged, we'll have to multiply an extra square root x inside the bracket. By doing so, we'll have the same indices of x in the numerator and denominator. Makes sense, right? Next, we take our square root x and square it, so it is x over 1 plus square root of cosine x. Now, we can put x equal to 0 into the limit. So the first fraction is 0 over 1 plus square root of cosine 0. For the term at the back, we make use of the limit of sine. So both of them are 1. Because square root of cosine 0 is 1. Finally, we get the limit, which is 0. See, it is actually not that hard, isn't it? If you want to know more interesting questions of calculus, please check out the links of the videos and the playlist on the screen and the descriptions below. See you in next video.